Welcome everyone. This is the last video that I posted and I don't think it is appropriate for my channel. So we're going to jump right back to beginner friendly videos, I suppose. So I started to code this controller, this car controller, and I thought it would be a good idea if I share it with you guys. This is super beginner friendly. So if you are planning to build a car game, a simulator game, or whatever game that might use these controllers or this logic, you are free to just use it or just get it from the GitHub link down in the video description. But anyway, this is what I have so far. Don't worry, I'll just delete everything and then start from scratch. Obviously, this is a beginner friendly video. But what I'm doing in here is that I'm just building this formula for the steering. So I'm doing this very scientific cube to show us that the wheels are actually turning into the right angle. As you can see, they are meeting in one angle. But the problem that we have right now is obvious, that this angle is not the same as the angle that is coming from the wheels itself. And that is because we are calculating the wheelbase. So if we make this wheelbase a little bigger, as we can see, or actually this wheelbase should be smaller, I suppose. And then we can have the exact same, or the exact number where this is meeting. But anyway, we are going to make all of this automatic, so we can just, put the wheels and keep moving. So what I'll do right now is I'll just delete the wheels completely. If you're wondering about this car model right here, I straight up just ported it from a GTA mod. So I do not have the rights. I did not make this myself. I am just using this for educational purposes. And don't worry, this also has a rim right here, which we can just, do this. And now it looks like an actual car. Let's try to build some sort of a controller, which I already have right here. So I guess I'll just delete this. Or actually, I'll just delete the whole entire car. And then we can start from scratch. So if you have a 3D model like I have in here, you can get this from the GitHub link, obviously. So if you have a model, this is what you'll get as a model. Don't forget to always reset this, because this is going to give you issues later on. And then this is our prefab for the vehicle that we're going to be using. It is a very good practice to just reset this on 0. And after we do that, I am going to keep this collision mesh. This is really handy for when we actually do collisions. So we're just going to add in a collider, not a box collider, but a mesh collider. And then we're going to make it into convex like this. And there we have our mesh. Everything else we are just going to delete. I guess we can use this shadow mesh, but maybe some other time, not right now. So now that we have that, we have another problem in here, that we have the scale set to 100. So we're going to just do this. Now the scale is at 100 and this is at 1, and we have this. And then we can just, reset all of this as we need. Let's give ourselves a little bit more room. So if this is set to 0, then this cannot be at 0, because obviously this is clipping. So we are going to make sure that the wheels actually touch the 0 axis, which is right here. So we're going to lift the car a little bit up like this, and now we should have normal. Okay, perfect. Now we have the car. Now we're facing this scale problem in here. We have this position set to 44. Let's just do this minus 90 so it looks nice and right. And let's take all of the elements that are inside of here and just put them into the first object. So now the first object is scale 1. And then we can just delete this. We're doing that because later on, when we add stuff to this car, we don't have to worry about the scale. And now I forgot to set the collision mesh. So let's just line that up really quickly. I think this is good. And one of the reasons that I always reset this is because this is dead center. So later on when we add the rigid body, this is going to stay right where it should be. So now we are just going to disable the mesh renderer like this, and there we go. Now we have our beautiful car. It's missing some textures, obviously, but that's not what we're here for. We are here to write some code and make this drivable. Anyway, now that we have the car itself, let's just try to remove this wheel. Actually, let's put this somewhere in here. And let's just disable this really quickly, like this. Okay, now let's go back in here and let's try to make this stand as a first step. So the first step to make this, a dynamic body is to add rigid. So when you add rigid body, this is obviously going to have some mass. So I think this car, or this Porsche, I suppose, has like 1400 kilograms, something like that. I don't know, I'm not sure. I'm just going to add this right now. And then we're going to see if it falls to the ground. And so far, so good. It is actually rigid, which is good. Next thing that we want to do is to add some wheels so it absorbs, the fall. Let's just add the wheels as an object in here. So I'll just add a empty like this. I'll call it wheel. And inside the wheel, I will add a wheel collider. Just like this. So now we have the wheel collider and the size of it is not messed up because we fixed the scale in here. So that is all nice and well. Let's just place this where it should be, like this. And instead of, doing this and messing up with the scale, which is not a good idea, we're just going to decrease this radius so it looks nice and centered. I wish we had a slider in here, but this is going to work for now. Okay, so now that we have it roughly in where we want it, let's switch to top view, or maybe bottom view, I don't know, whatever you feel like. Now let's try to center this where we need. So now that we have that, we can just duplicate this, and then instead of moving this from here to here, and this is inconsistent, what we're going to do is just remove the minus. And that will move it exactly where it should be, but in the opposite. And that is why we do the position resetting. So now that we have this positioned exactly where we need it to position, let's take these both and let's duplicate them. And then obviously we don't want to do this. So what we can do is just move this minus, but we're going to see that this is not going to work because cars have different wheelbases. So we're going to move it where we need it, and that's it. And I suppose we can move it a little higher up like this. And there we go. Now this should make our car actually on wheels. Let's try to play this. And if we step this each frame, we're going to see that it is actually falling. So if we unpause this, we can see that the car is actually doing what it's supposed to do. It is absorbing the fall really, really well, and it's not glitching. If you're having a problem with the glitching, it is 99% because of the position is not properly set or the scale. And if you're having trouble with that, it is most likely because of the collider. This can be offset and this can then twitch. So since we don't have that, let's continue building our game. I'm gonna make this a little darker because it's hurting my eyes. So now we have a clean sheet to work with. Let's go into our code, and I suppose we can get rid of this maybe. Or actually, I have a better idea. Let's comment this. And let's uncomment it as we build the app or the game. Okay, so let's think that we don't have this. Let's push this to the bottom. And when we create our script, if you're wondering how you can create the script, by the way, always it's a good idea to stay organized. So into our script, how you can create a script, just go create a mono behavior script. This is the latest version of Unity, I think. I'm not sure. I'm using Mac, so it's kind of new to me. But once you create the script, sometimes you cannot open it from here, so you have to go into Asset and open C#. And still, we don't have a compiler, but that's okay. We don't need a compiler. Anyway, when you create this mono behavior script, you are going to be greeted with the start and update, like this. So you will have these two methods that greet you when you create a new script. We are not into the input system yet. Anyway, so this, if we compile this, and if we drop it into our controller, we're gonna see there's nothing in here. Okay, let's start and add some stuff to this. So the very first thing that we need is, of course, the references. So what the hell did I just do? Okay, so let's do a public wheel collider wheels. This is a singular wheel, so we want an array of these wheels. If we compile this, it's not letting us compile because I have a problem. We cannot define wheels like this, but we have to define wheels like this. Okay, now that we have the wheels, we can just add stuff. Obviously, we can just drop in the wheels and that's it. But that is going to give us a little problem in the future. So that's why I opted to build this kind of class. So what this class does, actually, let's just build it again, I suppose. So let's do system.serializable public class. We're gonna name it wheel, and the wheel will have obviously a wheel glider. It will have a wheel type. We don't have a wheel type, so let's create a system serializable enum. It's a front or rear wheel. Okay, for now we have only front and rear. And then instead of doing wheel collider, we can just call this wheel. And now we have some wheels. So now that we have the wheels, we can say this wheel right here is the front wheel. And then we can just, define it as a front wheel or a rear wheel. We can do a Boolean in here, but later on, I think I'm going to add more options. So we're going to leave it as front. Now that we have that, the next thing that we're going to need is some input. So the input is always, or actually not always, but the forward and the sideways input is always a vector2. So let's do a public vector2 of move input, like this. In order to take this input, we are going to use the input system from Unity, like this. And this is going to do nothing for now. So we're going to have to add some more functionality to this. So if we compile this, go back to Unity, we are going to see that this obviously pops up. But in order to use the move input, we are going to need the input system. So like this. And if you don't have this actions, you can just click this window right here. I don't know what's going on with the windows, But you can click this window and you can put or select this input system. And obviously, if you don't have it, just go here, wherever this is, and just, create input system somewhere in here. I don't exactly know where it is. After you do that, then you have the input system and you need to do nothing else in here. So now back into our script, we are going to take this input as a event. So let's do void on move like this. So this is going to take us this is going to give us the input. So the way we're using it down here, if we take a look, is that we have a public void on move input value as a value, and then we assign our input move input into this value. So if you're scared of this sign right here, this is basically doing this. And if you're not, or if you don't want to just use this move input, it's a really good practice to just console, actually not console, but just print. And you can just, print this vector2. So since this is a callback, or since this is a event, I should say, every time this gets called, we print this, and then we don't have to check each frame. So now if we try to play and go into the console and hit a key, we're going to say, or we're going to see that the vector is changing. So if I press forward, now we are at 1. If I release, we're at 0. So that is all we need for the input. And since we have the input, what we can do is just pass it as a move input, as a vector2. So now that we have the vector2, we should see that just ignore this. After restart, this is going to go away. So now that we have that, we can just go play, and we're going to see the Y input and the sideways input. It's really convenient because it goes from -1 to 1. And if you're using a controller, this is going to be sensitive, so it can be like 0.7 or 0.3 or whatever, how hard he is hitting or pressing the button in his controller. Anyway, now that we have that, I'm going to delete this line, and then we are going to create a fixed update like this. So in the fixed update, what we want to do is we want to make these wheels turn. That's all we want to do. So in order to do that, I'm just going to declare a power multiplier. We're going to set it to 1 for now. And then we're going to say a for each loop in here. The loop will loop these items from the collection of wheels. So for each wheel, we are going to iterate through. So the item dot collider dot motor torque is equal to move input times the power multiplier. So we're taking only the Y because we want to do motor torque, and then we're going to take the X to steer the wheels. Now that we have that, let's actually assign these. So we have the first wheel as a front and the rear wheels. Let's not forget to set them as rear wheels. And if we try to play, we're going to see that they're actually turning. They have almost no power, so we're going to give it some power. Like this. The only problem is that this is moving backwards. But the other problem is that this is not actually moving backwards because I'm pressing W and it should go forwards. The issue is that the blue axis indicates forward. And that is correct. When we press W, this goes forward, which means this way. The problem that we have is that everything in here is not facing that direction, where it actually is, but I don't know why it is rotated. So what I'll do is I'll just do this. I hope this fixes it. I'm not sure if it does. I'll just give it a shot. It actually does. Okay, so now that we have the forward axis as the blue arrow, and we have some power. Let's try to build a formula for the steering of the wheels. So actually, I already wrote it in here, and it's really sort of complicated on what it does and how it does everything. So what we're going to do is the simplest thing. I'll just copy everything, and I'll just do it right here. And I will move these two down here, just so we have some readability. I made the font a little bigger. Maybe you can't see it really well. So here it is. So really quickly, what this formula does is some trigonometrical equation. So what it does is it takes the radians and turn them into degrees. So we know the actual angle. Then we use this tangent function. I don't exactly know what it does or how it operates, but it does, and it gives us what we need. So if we save this, actually we did not have this yet. So let's comment this out. So if we save this, go back into Unity, we should see a wheel turning. So if I press S, we're going to see it actually turns. And I think it already turns into an angle that is what we are looking for. But in order to see that, we can't just put some 3D object like this, because unfortunately, when I actually move the wheels or turn the wheels, this does not turn. So we have to translate some stuff. So we already have a transform in here that is connected to this wheel, but this wheel and this rotation is not connected in any way. So if we go into play mode, we're going to see that it does nothing to the wheel collider itself. We can play with any rotation we want, it does nothing. The only thing that matters is the actual position. We're not going to mess with the position, we're not going to mess with the scale, we're only going to mess with the rotation. So let's go back into our script and let's do this very simple calculation. So what we're doing in here is we're taking the transform of this collider. So as I already stated in here, we're taking this transform and then we're just giving the rotation from the wheel itself, or from the collider itself, wheel collider. This quaternion is a little complicated to understand. I personally have worked with these for a very long time, but I still don't understand them 100%. But anyway, we want to set the rotation from this to this. So if we go and try to play the game, we should see that this is in fact working. We're also going to see that this transform or this rotation is only working in the world axis, which is not very good. So let's try and do local rotation like this and hope it works, because I have no compiler working in here. I don't know why it's not working. Maybe it's because I'm using a Mac. I don't know. But this seems to be working. I don't know why the power is so low. Okay, so this seems to be working swimmingly, I would say. Let's add another one of these into the other wheel, and let's try to see if they meet up. And in fact, they do. So if we don't use this formula, this is going to be parallel with this. Then we're going to have always one of the wheels just drifting and drifting and drifting and not making good contact with the ground, which is not what we want. We want a somewhat realistic game. So now that we have that, I think we're going to end this video. This is getting way too long already. Okay, so in the next video, we are going to make this automatic. We are going to try and automate as much as we can. And then we are going to try and fix the meeting point from here to here, so we have a consistent, turning. And we're also going to try and fix the actual rotation. But for now, thank you for watching. This video is gotten a little long already, but thank you.